morning and good evening, everyone. I'm honored to have the opportunity to give this presentation here today. Thank you very much. As you know, niobium is a very attractive material for a wide range of science and technology fields. Recently, especially for batteries. So Professor Yaguchi presented very interesting cathode material and the aqueous battery. Today, I'm going to talk about next generation lithium battery with niobium-based anode. So this is the content of my talk. First of all, I'll explain about our background of technology. Then I will talk about niobium titanium oxide anode material. We named this NTO. After that, I will show you what NTO battery can do. So let's start from the background. The first slide shows the challenge of carbon neutrality by 2050. As you can see here, more than half of CO2 gas emissions in Japan were from industry and transportation sectors. Above all, the transportation sector is receiving a lot of attention as a familiar environmental issue. Take a look at the CO2 emissions in the transport sector. The private vehicle and the commercial vehicle account for the majority. So the electrification for these sectors would be a pressing issue. Especially, the commercial vehicle requires high operation rate and durability for heavy duty and long range of usage, while the private vehicle can be used even with a long charging time because it's mainly used for daytime only. Thus, the next generation batteries with high power, high durability, and ultra-quick chargeability with safety will be strongly desired for the electrification of commercial vehicles. From such a background, we developed a unique lithium-ion battery named SCIB. This battery has a lithium titanium oxide anode instead of a carbon-based anode used for conventional lithium batteries. This battery has many attractive advantages such as safety, long life, wide SOC operation, quick chargeability, high power, and low temperature operation. These properties are realized by using LTO anode. From the characteristic of SCIB, Toshiba is focusing on the applications for heavy-duty areas. This figure shows the target markets of several kinds of batteries. The horizontal axis shows cycle life. The vertical shows the charging time. We are aiming at this blue area where high durability and quick chargeability are strongly required, and it would be difficult to apply with conventional lithium batteries. So these commercial vehicles could be electrified for CO2 gas emission reduction by using our SCIB. Then the electrified mobility will realize mobility as a service, MaaS, in the near future. The demand of EV cars for ride sharing and public transportation will be increased. This is the point. Vehicle ownership will be changed from personal to service providers. Thus, even the requirements for the personal EVs will be changed. So far, the value axis for the electric vehicle batteries was just focusing on energy unit cost and energy density. However, in the near future, we should consider new value axis such as high availability and durability during the product life for the mass applications. There is another view on this point. We should consider the environmental impact by battery waste. Battery production will reach 1,000 gigawatt-hour equivalent in 2030, and in a few years later, 5 million tons of battery waste will be discharged every year. So how to reduce the battery waste is another important challenge for us. Toshiba is now investigating reuse model of our high durability battery in order to conserve resources and reduce waste. We should reuse batteries of EVs for the stationary power grid and so on. Next, I'll talk about niobium titanium oxide material. This is the key material for the next generation battery. So far, I talked only about the strong point of our CIB, but there is a weak point as a battery for electric vehicles. This schematic figure shows power density as a function of energy density. As you can see here, our FCIB has high power comparable to the capacitor, but lower energy density compared to the conventional lithium-ion batteries. So lack of sufficient energy density is the biggest weakness of Toshiba's battery. Toshiba's challenge is to enhance the energy density, which is mainly determined by the low capacity of the LTO, lithium titanium oxide anode. Therefore, our anti-pellet new anode material is niobium titanium oxide. Let me introduce it from the next slide. As you know, a niobium is a metallic element with the symbol of Nb and the atomic number of 41. This niobium is widely used for not only metal products like this, but also optical products. The anti-pellet material, niobium titanium oxide, is a kind of ceramics with a rigid framework consisting of niobium and titanium. This material has a large space for lithium-ion storage and thermal stability up to 1000 degrees Celsius. This table shows the features of NTO anode material. Compared with currently used LTO and conventional graphite, as I mentioned, we are now focusing on the development of niobium titanium oxide. This material has much higher energy density compared to LTO. Especially the weight density, energy density is comparable to the graphite. Moreover, the volume energy density is twice as much as graphite. That's why we are keen to develop this niobium-based material. The next shows the comparison of theoretical energy density on anode materials. As you can see here, NTO shows much higher energy density than LTO, as I explained in the last slide. However, looking at the battery voltage, NTO shows the lower voltage as the same as LTO. So the battery energy density would be still lower than conventional lithium-ion batteries. However, we are committed to the low voltage battery using NTO anode. I will explain about the reason in the next slide. As I explained in the background, the ultra-quick chargeability with safety will be strongly required for the next generation batteries. We consider NTO battery can do that because NTO shows almost no structural change compared to the graphite. So NTO would be almost no damaged even under the quick charging. Moreover, NTO has a safety margin against the lithium dendrite formation. The graphite anode is very close to the lithium metal formation potential, and it has a very high output voltage, but there is a possibility that the lithium metal dendrite could be formed in the electrode under the quick charging cycles or low temperature conditions. This may cause an internal short circuit and a battery explosion. NTO battery has almost no worries about lithium dendrite, even under the extreme conditions. That's why we are committed to the NTO anode. Even if the output voltage is lower than graphite, we have the safety margin against the lithium dendrite formation. Here, I will show you the NTO battery performances and what NTO battery can do. This slide shows a summary of trial-produced 49 ampere-hour battery. This battery achieved almost 50% larger capacity compared to commercial SCIB having LTO. Nevertheless, we can also achieve the safety, no explosion, even after nail penetration, and long life, more than 10,000 cycles, and 6 minutes ultra-quick charging up to 90%, low temperature usability, even at minus 30 degrees Celsius, and high input power, more than 12 kilowatt per liter, which is much higher than SCIB. So Toshiba suggests the ultra-quick chargeable EV within 6 minutes by using NTO battery. The driving distance per charge will be shortened compared to the lithium-ion batteries. However, 6-minute charging will be acceptable for commercial EVs, such as EV buses, trucks, and so on. The NTO battery can be recharged during the driver's break, while the conventional lithium-ion battery needs a long time to charge. So NTO battery will play an important role in the electrification for the transportation sector. This table shows a summary of NTO battery features compared with the other chemistry batteries. As you can see here, the NTO battery can achieve almost the same energy density as a lithium iron phosphate, so-called LFP type lithium-ion battery, and has many attractive advantages as well as our SCIB, as shown here. So we believe that a combination of Toshiba's technology and NTO will bring an outstanding battery and make the impossible possible for the electrified society. We have lots of battery-related technologies, not only materials, but also computational technique and so on. So please look forward to our new battery using niobium-based material. Lastly, I'd like to thank CBMM for kind cooperation. Toshiba has just announced a new joint development agreement between Sojitz and the CBMM. The mission is to commercialize a competitive new lithium-ion battery using niobium titanium oxide. Also, we are pleased to inform you that the NTO prototype battery will be installed on the new electric vehicle designed by Volkswagen Caminhões e Ônibus, and we will collect the valuable vehicle operation data. So this is all for my presentation. As you can see, Toshiba is keen to develop new battery technology using niobium under the friendly relationship between Brazil and Japan. Please look forward to our new battery. Thank you so much for your kind attention. Thank you.